Fellow examiners, lecturers and friends, my name is Xuan. I'm a final year mechanical engineering student from SEGi College, Penang. In this video, I will demonstrate to you my final year project, prototype model, which is a hybrid cool roof. And my FYP project title is Design of a Sustainable Hybrid Roof Cooling Model to Improve Attic Temperature Reduction under Malaysia Climatic Condition. My hybrid cool roof comprises of both active and passive cooling technique. So let me explain to you what is active and passive cooling technique. So passive cooling technique is a natural cooling method that doesn't require any mechanical motion like fans or pumps for its cooling operation. Let me show you some example of passive cooling method. So for passive cooling method for roof, we have roof color, roof material selection, and also natural ventilation. However, on the other hand, active cooling technique, it requires mechanical motions, for example, like fans and water pump for its cooling operation. So there are some example of active cooling, which is active attic ventilation and also direct evaporative spray cooling system. The main design objective of this hybrid cool roof is to actually improve the attic temperature reduction by means of both passive and cooling technique. Also, I would like to stress that my hybrid cool roof model is 100% solar powered. It doesn't require any domestic electricity for its operation. Instead, it uses the electricity generated by the solar power generation, which I've constructed for this project. Without further ado, let me show you my hybrid cool roof prototype. This thing right behind me is actually my hybrid cool roof model, and let me show you one by one of what I've implemented from my hybrid cool roof model. This is the attic housing model that I've constructed for my project. It has a roof inclination angle of 15 degrees, and also at the front end, it has a vent grill for attic ventilation purpose. Right here you can see, this is a white metal roof deck. The reason why I choose white color metal roof deck is because of its high solar reflectance index, also known as SRI. The high solar reflectance index of white metal roof deck is increase the tendency to reflect the incident solar radiation and decrease and also reduce the overall heat gains from the roof surface to the attic space. And this is one of the passive cooling technique that I explained it to you earlier. And the second passive cooling method that I've used is the foam insulation. As you can see, yellow color over here, right below the metal roof deck, we have this yellow color foam insulation. And this foam insulation that I use is the polyurethane foam, also known as PU foam. It has really good thermal resistance that helps to impede the heat transfer between the roof surface to the attic space, and also helps to reduce the overall heat gains at the attic space. Right beneath the roof layer, I've constructed a ventilation duct, also known as active ventilation exhaust duct, AVET. So basically, it has three vent holes. One is the inlet, and this is the attic inlet. And at the back here, this is the attic, this is the AVET outlet. Right here, this is the rear view of the active ventilation exhaust duct. So right here, we have three outlet vents, where I installed three exhaust vents at the outlet vent hole. The purpose of having this exhaust vent was to induce a mechanical airflow throughout the ductwork and also increase the heat removal rate from the attic to the atmosphere. And this is one of the active cooling technique that I implemented for my hybrid cool roof. Right under it, we have another inlet vent and also another fan facing the attic space. And the function of this fan is to actually provide mechanical ventilation at the attic space and also remove the attic heat to the atmosphere through the duct. This active ventilation exhaust duct is 100% solar powered, and it is also an automated system where it will turn on during the daytime when the solar intensity or the light intensity is high, and it will be automatically shut down when the light intensity is low during the night time. The second active cooling technique that I have implemented for my hybrid cool roof is called direct evaporative roof spray cooling system, also known as DRSCS. So the cooling concept of this system is rather easy. It uses water to cool down the high temperature roof surface by the evaporation of water, and where the four nozzles over here will be spray out multiple streams of water droplets and cools down the heated roof surface when it is activated. This DER SCS system is a completely automated system where a digital thermostat will be used to control the operation and also the activation of the system. This system will only be operated or activated when the rooftop surface temperature reaches 50 degrees Celsius or above, and it will be cut off when the rooftop surface temperature reaches 30 degrees Celsius or below. So the operating temperature range of this system is between 30 degrees Celsius to 50 degrees Celsius. In the meantime, I've also implemented a rainwater harvest system to collect the rainwater, and the rainwater will be used as the cooling agent for the evaporation process. So this is the gutter, and the rainwater will be collected through the gutter and then to the container, and it will be cooled down to the cooling tower over there. Right here, I constructed a cooling tower, which I call it as induced draft cooling tower, to actually cool down the recirculated heated water and reuse as a cooling agent for the next round of operation. And this helped to reduce the reliance on domestic water, and it reduced the water consumption for the entire process. Due to the unstable outdoor weather condition, I carry out my experiment in a closed indoor space with minimal disruption from the outdoor environment. And so, because of the absence of solar radiations in the indoor space, I am using this halogen lamp, and this two halogen lamp is a 250 watt halogen lamp, which will be used to simulate and also to provide the solar heating effect to the model for experimental testing. Right here we have the two halogen lamp. It is a high power rating halogen lamp, and are positioned on top of the rooftop surface, and it helps to provide and also to simulate the solar heating effect to the rooftop surface for the experimental testing. This solar panel will be used to collect solar energy and convert to electrical energy, and the electrical energy will be converted through the solar charging controller over here, and it will be stored as a backup energy in this lead acid battery. This is the operation of the AVAT, where the hot air, the dust is constantly being removed to the atmosphere by the 3 exhaust fans. Next, we have the direct evaporative roof spray cooling system, where water is being used as the cooling agent to cool down the high temperature roof surface. So let's look at the close-up view of the operation. As you can see, the nozzle is constantly spraying out the water droplets onto the roof surface to cool down the high temperature roof surface. So right here, the unevaporated heated water will be recycled and reused as for the second round of cooling operation, where the heated water will be cooled down at the induced draft cooling tower before the next round of operations.
The exhaust fan placed on top of the cooling tower will help to remove the hot steam to the atmosphere, which is the byproduct of the water cooling process. Inside the cooling tower, the heated water will be discharged in the form of smaller water droplets, which helps to increase the heat removal rate by increasing the air-water contact area. After the water is being cooled down, it will be collected and stored at a chilled water storage tank located below the cooling tower and ready for the next round of roof cooling operations. Finally, a total of 4 key-type thermocouples will be used to measure the temperatures at 4 different locations, namely the surrounding ambient, rooftop surface, upper and lower attic. All the temperatures will be recorded in every 1 minute throughout the 30-minute experimental testing.
Last but not least, I would like to thank each and every one of you for watching my video. I hope you now have gained a better understanding of my hybrid cool roof. Thank you so much, and see you.